Good evening. I am welcoming us to Wednesday webinar session. In this session, we are going to be looking at big data. The word big data is a very familiar word, or let me say a very important term in the data ecosystem. So let us get at it. We are going to be looking at what big data is, the cardinal features of big data, and we are going to be looking at the IoT devices. And if time permits us, we will also look at some of the other important terms that we could not complete on Monday session. Big data is a term that is used to describe data with enormous value and complexity, which cannot be managed by traditional data management tools. So big data is so voluminous and so complex that we cannot use traditional tools such as spreadsheets and some traditional databases to manage them, either to store them or to analyze them. So big data actually has some specialized tools that are designed for them. Now, when we want to talk about the features of big data, there are 5 cardinal features. Every other things can come after that. But you as a data pro, when the word big data is mentioned, these 5 features must come to your mind as quickly as possible. The first one is the volume. Like I said, they are data of large volume. And a good example of big data is the data on social media platforms, such as Telegram, this one we are using now. Telegram has millions of users all over the world. And these users are generating data every second, every minute. So these are data of large volume. Another example is YouTube, Netflix, and so on and so forth. Now, the second V is the variety. So big data is a data of several variety. Let's come back to the Telegram again. Millions of users are using Telegram at the same time, but they are generating different categories of data. Some are uploading videos, some are uploading audio files, some are uploading text files and code. So big data is characterized with this variety. The third V is what is called the velocity. So if millions of users are generating data on the same platform, then we can see that these data are generated at high velocity. Another example is YouTube. Millions of users are uploading videos, streaming videos, and doing different things at the same time. So it means that these data are generated at very high velocity. The fourth V is veracity. Veracity is all about the authenticity and the validity of the data. Then value. Like we said, if we have data that is of great volume, of different variety, being generated at high velocity, then it is straightforward to say that this data will contain large value. And believe me, some of the advancements we are seeing today in technology, even in research and science, they are as a result of value generated from big data. For example, ChatGPT is everywhere now, but believe me, ChatGPT was trained on almost all the available data on the internet, which is actually a big data. So we can only have applications and systems like ChatGPT basically because of the presence of big data. And big data is made possible because of the advancement in technology and some of the IT infrastructures. So big data is an outcome of the revolution of the digital age. And that is why it is one of the reasons why being proficient in analyzing data and handling data is a very good skill in this era. Big data is so deep that some people even go as far as doing their PhD in big data engineering. So this is a whole world of its own. Now we are going to be talking about another term called the IoT devices. IoT means Internet of Things, and there are devices that are classified as IoT devices. And these are devices which are embedded with sensors and other technologies to transfer data from one system to another all over the internet. So these devices contain sensors in them, and they also have processors, and they can transfer data from one to another over the internet. Now, when we talk about the features of the IoT devices, we talk about connectivity because these devices are connected and is possible via the internet. The second component is they contain sensors and processors. The sensors pick the data, and then the processors do the instant processing of the data. And then there is opportunity for real-time data processing. So as the sensors are picking the data, they are being processed and instant analysis could be done. A good example of IoT devices are some of our wearables. Some of us have wristband, or even some of us have phones that measure our heart rate, the number of steps we take per day, and so on. What we should know is that all of those informations are being transferred to the databases of the manufacturer of those devices because they are connected. So the sensors in your phone can measure the number of steps you have taken, and it can even measure your heart rate and co. But those data are also being instantaneously processed and sent to other places, usually database of the manufacturer. And this method is used. For example, in weather stations, how do they know what is happening in a particular location at a particular time? Is by the help of these sensors that generate data and process them in real time. One of the good applications of this is some healthcare facilities abroad. Some of those facilities, what they do is that when they have patients with chronic illness, such as hypertension and diabetes, they give the patient some devices to go and monitor themselves at home. So, but those devices contain sensors such that if the person measure his BP in the morning, that same value is transferred via the sensor inside that gadget, and the information is transferred to the facility, the healthcare facility, and is being stored there. But that is also connected to another group of sensors so that if the value of any patient is more than the expectation for that particular money, the sensor is going to trigger an alarm system that will make the people in that hospital to know that even though 1,000 people have measured their BP this morning, this particular group of people have elevated value of this magnitude. And that is why in those places, if somebody has an elevated BP, they will call the person and say, sir, we can see here that your BP is extremely high this morning, report in the hospital. And if it doesn't do so, they will carry ambulance and go and bundle the person themselves. So that is the example of how these sensors work. Another example is when you look at football. Some of us who watch football now, we discover that as we are watching the match, the commentator can just say, so and so has touched the ball 25 times in the last 15 minutes. The question is, how does the guy know that? He knows that because there are sensors inside the cameras they are using to cover the match. And some sensors are even on the pitch and co. So those sensors, they carry all of those information and transfer them for real-time data processing and real-time data analysis. So that is how IoT devices work. And IoT devices is one of the components of the infrastructures today that is contributing immensely to the generation of big data. So one of the greatest contributors of big data today, apart from the normal social media platform, is also the IoT devices, the Internet of Things. So I believe that some of us should actually go and do more research concerning this particular topic, both big data and IoT devices. As a data professional, you should be conversant of these concepts. So in conclusion, we have been able to look at big data. What big data is, the fact that big data is so big, is so complex, and is being generated at a very high velocity, and they are of different variety, that they could not be handled by traditional data management system. So, and is such a big industry that people go as far as obtaining their PhD in big data engineering. And we talk about the characteristics of big data, about the 5 V's: the volume, the variety, velocity, veracity, and the value. And then we spoke about the IoT devices, that these are devices that contain sensors and processors which are connected via the internet. And we also established the fact that apart from the social media platforms, that IoT devices are also one of the major contributors to the big data that is available today. So good. Now, let's quickly look at some of the terms that we could not complete on Monday. So today we are going to be looking at ETL. ETL, as a data professional, you must know the meaning of it because it's so fundamental and is just so basic. So ETL stands for 3 processes. The first is extract. So this is the collection of diverse forms of data from different sources. So the point is that when you are working in an organization or you want to do any data project, you are going to be needing data from different sources. For example, if they ask you to work on the data of a particular company in order to generate some values and also to evaluate some of the performance of the company for last year. You cannot do that by getting data from one source. You have to extract data from different sources, from customer data, the HR data, the production data, sales data, marketing data, all sorts of data, even inside just one organization. So the process of extracting those data from those different sources is called extract. So you have to extract your data from different sources. Sometimes you may have to extract from even external sources. And then we have the second stage, which is called transform, which we spoke about data cleaning in the previous webinar, that is on Monday webinar. Now, transform is that when we have extracted our data from different sources, we can't just start analyzing the data like that. We have to transform the data in such a way that it is going to be useful for our analysis. So, transform stands for how data is transformed into, or let's say a stage where data is transformed into a format that is going to be useful for the process of data analysis. And then we have the third stage, which is load. So load means that after we have extracted our data, we have transformed it, the next thing that we want to load the data into a particular place where we can come anytime, any day to make use of that data. So it's like saying extraction of oil. So they extract the crude oil, they carry it to the refinery. So that's like the transform stage. And then after they have extracted different oil from the crude oil, from petroleum to diesel and coal, all of these are now stored in different depots where people can come and collect them and be transferred into the society. The same thing goes for ETL. So we load a transformed data like a refined oil. We load it into a desired data repository where we can start using them for our analysis. Note that this process is often automated. In organizations, they are usually automated, and we are going to be showing us how we can do some of this even with spreadsheet. As simple as spreadsheet is, we can do some automation with it. So, but in large and big organizations, there are specialized tools which are designed for this. And this is usually done by data engineers in big organizations, but for small organizations, you may have to do your ETL yourself as a data professional. Now, let's talk about data pipeline. Data pipeline is a broad term which encompasses the process of data flow from one system to another. So, data are present in different sources, but how can we transfer them from these different sources to another place where they can be useful? That is called data pipeline. It's a whole word of its own. And ETL is an example of data pipeline. Also, what is called data stream. Now, what is data stream? Data stream is the real-time streaming of data. For example, millions of people are using Telegram at the same time. So all of these data are being streamed into a particular location, and this is a whole world of its own. This requires high level of technicality, and even the infrastructures can only be afforded by big institutions. So this can handle complex multi-step workflows, such as the ones used in advanced machine learning systems. So we are still going to talk about what machine learning is as we continue. Like I said, it requires a high level of expertise and it is the go-to technique in the usage of big data. So in conclusion, data cleaning ensures that our data is ready for analysis. Data wrangling ensures its fitness for analysis and transformation, making our analysis smooth and organized. So, like we said before, data cleaning is 80% to 90% of the work of a data professional. Like it is always said, garbage in, garbage out. If you use bad data for analysis, you are going to get bad insights and your conclusion is going to be bad. And that is going to cause a very great issue. Because by the time you come today and tell the stakeholder that our sales, our profits, our sales has been increasing over the last 6 months. And 1 month after, they discovered that some of the data that you used, there were a lot of repetitions there, like a lot of duplicate value. So a customer came once, but the, the software that is being used actually replicated that transaction. So instead of having $1,000, you are having $5,000 for the same transaction because you didn't clean your data to check for duplicates. Where you have been able to discover that there are some duplicates, remove those duplicates and only use the single entity. So because of that, you are able to generate big value, which is not true. That is going to impact the decision making of the stakeholders. Is going to make them to lose confidence in your work and go. And that is why if you build a machine learning algorithm with a data that is not well cleaned, you are going to be getting a very bad output. In about 2 months ago, Google Gemini released a particular feature where Google Gemini was trying to generate video. It was a disaster, and Google had to remove that feature within 1 week. Why? Because people asked Google Gemini to give them the picture of the president of America in 1930s and 1940s, and Google Gemini was showing them the picture of a black man. So why? Because the machine learning algorithm was trained on a lot of data which was not well transformed and well cleaned. And that was why the algorithm was confused and was generating nonsense. It was generating bias and all sorts of terrible outputs. So it has to be removed. So, and that is an example of even how big boys can mess themselves up when you do not handle your data effectively. So don't jump to conclusion. As a data professional, when you want to start your job, sit down with the data, clean it. The cleaner your data is, the better result you are going to generate. And believe me, that is going to help your conclusion, your insights, and the confidence that people will have in your work. Now we talk about the trend. That trend is measured against time, while pattern is a recognizable structure and behaviors. So trend is what has happened over time. ETL and data pipelines are two important processes of making data from different sources useful for analytic processes. So we need data pipeline to be able to transfer data from different sources to a particular location where it is going to be useful for the process of analysis. Thank you very much for this session. We are going to be meeting on Friday by 9 p.m. for another session. Thank you very much. We are going to be meeting until then. Please let us start going through our materials everywhere they are. So some of us are on the Telegram pages. Every information about our courses are there. So let us check our paid messages. The paid messages contain everything we need to know about the program. And some of us who have not checked the first session on Monday, that session is very important because it contains everything we need to know about this particular program and program. Thank you very much. I wish you all the best once again.